Hello everyone, welcome back to another video. Myself Jayadeva M R from C section CSC AML department. In this video, we are going to submit our first assignment of machine learning. The topic about our assignment is customer spending classifications using KNN decision tree and Navi Bayes. My teammates are Ashish, Nithin, Rahul, and our guide for this assignment is Mrs. Shivaranjani SS, Assistant Professor of AML Department, GM University, Davangere. Let's move on to introduction. Customer classification based on spending behavior, like they may spend low, high, medium, helps business with targeted marketing and segmentation. This study compares KNN, decision tree, and Navi based models using key features like age, gender, income, and spending score. The goal is to evaluate accuracy, precision, recall, and efficiency. The MOL customer dataset of Kaggle was used for training and analysis. So overall in this assignment, we are going to track the spending of of an individual, which includes features like age, gender, income, and the spending score. So the databases we are going to use in this are customer ID. We'll use it as a unique identifier. Uh, we'll use it as a unique identifier. Gender, either it may be male or female. Age, it's the customer's age. Annual income, we are going to calculate their annual income in words of thousands per per year, how many thousands they're gonna earn. The next is spending score. We're gonna scale this spending score from 1 to 100, where 1 is the lowest and 100 is the highest. So the next is carried out by my colleague Ashish.
Thank you, Jaydev. Today I'm going to speak about data preprocessing. Here, it converts the categorical data into the numerical values. Here, the male is converted to 0 and female is converted to 1. It normalizes the features such as the age, income, spending score using the min-max scaling. Then it splits the data into 80% training data and 20% testing data. It handles the missing values and removes outliers using box plots. Then it uses one hot encoding for categorical variables. One hot encoding is a technique used to convert categorical variables into a numerical format that machine learning models can understand. Now, k nearest neighbors. It's also known as KNN. It is a classification algorithm that finds the k nearest neighbors using Euclidean distance. Here, the k stands for the number of neighbors, and it's computationally expensive for the large data sets. It's non-parametric, that is, no assumptions about the data distribution. Then it's implemented using this one, the k-neighbors classifier. And the further slide will be explained by my teammate Nithin.
Thank you, Ashish. Now let us discuss about the decision-making tree algorithm. Where a tree-based model that splits the data using if-else condition. It is where the data splits step by step like a flowchart, making decision at each node. Next is like selects features that maximum information gain. This is where the chooses the best attribute to split the data for our better accuracy. Next is like interrupted and work well for categorical data. In this very easy to understand and effective for non-numerical data. Next is like prone to overfitting, like especially when depth is too high, like where can memorize the training data, reducing accuracy on new data set. Next is like feature importance ranking helps in selecting key features. In this, which helps identifies the most variables for prediction. Next is like purring techniques like post post purring can prevent overfitting. In this way, which reduces tree complexity to improvise generalization. This is like the code snippet where we used in like decision tree algorithm. Now let us discuss about Navy based algorithm. In this, based on biases theorem, assumes features independence, where we calculate probabilities assuming features does not affect each other. Next is like works well with small data sets and continuous numerical data. In this, where we performs efficiently even with limited data. Next, we go on to users Gaussian Navy basis for continuous features. In this, like where we assume data flows follows a natural distribution. Next is like work well with small data set and it is more computationally effective. It is like where work easily and flow easily, where the data sets run normally with the limited data sets. Next is like performs poorly if features are high correlated as if it assumes independence. In this, like assumes all the features as independence, which is not unrealistic. Last is like often used in spam detection, test classification, and medical diagnosis. These are the few examples of Navy-based algorithms, where this is like code snippet which is used for Navy-based algorithm. Next slide will be explained by our friend Rahul. Thank you.
Thank you, Nithin. It was more informative. Now, here let us learn about model performance comparison, decision tree, Navy base, and KNN. The decision tree achieved 100% accuracy. It is overfitting, and rest Navy base is a simplistic assumption, and KNN is a good accuracy but sensitive to K value selection. Here, let us see the model of KNN decision tree and naive base, accuracy, precision, recall, and defense score. The accuracy of KNN is 90%, decision tree is 100%, and 95%. Precision is 91%, 100 and 95%. Recall is 90%, 100% and 95%. And defense score is 90, 100 and 95%. Let us move on to observation and insights. Decision tree performed the best but might be overfitting. Navy base is computationally efficient but assume future independence. And next, KNN performs well but computationally expensive for large data set. Choosing the right model depends on data size and future importance. Future importance. Hyperparameter turning future engineering is the future importance here. And enable techniques like random forest can improve the decision tree performance. Real world applications are customer segmentation for targeted marketing, and model selection depends on the data size, interpretability, needs, and accuracy requirements. Conclusion and future scope. The best model is here decision tree, but needs burning for generalization. Business applications are helping in customer segmentation for marketing strategies, and future work is trying random forest, SMV, and deep learning for better insights. We can implement the random forest, SMV, and deep learning for the better insights in the future. The key takeaways of this model is model selection depends on data distribution, complexity, and speed. Thank you.
Okay, thank you, Rahul. Thank you for your correspondent explanation. So now let's come to the part of code. Here we'll import all the files required, all the necessary files and library files we required. And here we are going to load the data. The data is given in an CSV form. You can see here we have around 200 customers. One second. Yeah, we have 200 customers. We have a column name called gender, age, annual income and their spending score. So from this we are going using read CV. We are going to take income. So next we are going to make an drop down column for a customer ID. We are going to encode. We are going to encode the gender, like as I said, male will be given 1 and female will be given 0. So next we are going to define the numerical, we are going to scale and define the numerical features. We are going to scale the numerical features and define the numerical features. Then we'll split the data into training set and testing set. As Ashish said, 20% is of test set, and the remaining 80% is for training set. We are going to split like that. Then we are going to apply all the three algorithms here, like KNN algorithm, Navy algorithm, and decision tree algorithm. While applying we'll apply all these algorithms to make sure which has more accurate accuracy, more accuracy. So here at the last we'll print the accuracy. So now let's run this code and test. We'll go here, we'll save the code first, and then we'll run it. Yeah, as you can see, we have got all the three types of classification reports. So first one is KNN report. KNN classification report, we can see the accuracy is 0.9. The next one is Navi based classification report with the accuracy of 0.95. Then we have decision tree classification report with the accuracy of 0.95. We can observe here both Navi based accuracy and the decision tree accuracy is almost equal, and KNN accuracy is 0.075 less, that is 0.9%. So this is the end of the assignment. Thank you everyone for watching.